course in Akdeniz University. So today we are going to talk about the new course content for today. So let's go to the courses webpage. I'm going to re-talk about the machine learning part. I know we already introduced the machine learning during the course time. We were ahead of this schedule. But I'm going to re-talk about the machine learning, big data, and the data science concepts for a few videos, starting from this video. How do we do the machine learning during the real-life actions? So let's go back to the course content and let's talk about the new approach starting from this week. So basically, the new approach about the machine learning part is the changing the viewpoint. So for example, until this point, until this week, we have talked about some rules and data, and using the traditional approaches like the logic or the fuzzy logic or the game trees, we have the answers. So for example, take about the chess playing. We have a problem, chess playing. We have some rules about how to play this chess. We have some data about the setup on the board or some information about the opponents, and then we make some decisions and we answer the next move on this chessboard. So this is the traditional approach for playing chess with using the game trees, for example. But using the machine learning, we change the viewpoint. So from the answers and data, we try to extract the rules. So for example, you have the chess playing, history of the chess playing of these, let's say, famous chess players, and then you have this data, you have answers like how these players are playing on the board, and then you extract some rules. So for example, you try to find some patterns, some repeating moves on their characteristics, on their playing approaches. So basically, the new approach about the machine learning is extracting the rules instead of getting some answers for some already known rational questions. Before getting into the details of these concepts, let's first define some key words, key concepts in this area. So basically, we are talking about the data science or the machine learning, and there are lots of terminology on the internet, on the industry, let's say. So it's very important to define these key concepts, the terminology, before we start anything. So basically, KDD can be considered as the border of the data science. So KDD is the shortcut of knowledge discovery on the databases, or sometimes they use it as the knowledge and data discovery. A minority call it as this shortcut. And also the KDD has, in the core of the KDD, in the center of the KDD, we have the data mining. So data mining is the technique or the philosophy or the methodology or the discipline on the core of the KDD. What do we have in the different part of the KDD and the data mining? If you ask a question like this, the KDD has some different approaches, different applications of the data mining. So for example, take about the business case, or let's say agriculture, or let's say fishing, or any other concepts. You can apply data mining on this area, the business problem. So there is a gap between the data mining and the KDD. So these gaps are filled with different disciplines, the applications of the data mining concepts. We have a database in here. It started from the databases and then converted to the very large databases, VLDB. And now we are talking about the big data in this part. So we need to hold the data in somewhere. We need to process it. We need these servers. We need these platforms, infrastructures, and so on. So you need to store this data in somewhere and process this data somehow. So this part is mostly dealing with these problems. And then we have the AI coming back from the computer science, and computer science is coming back from the mathematics. So it's a human-centered discipline. So you can just separate the science or the disciplines under the science into two by using an approach, let's say. In one part, you have the human-centered approaches. Let's say mathematics, economy never existed if there is no human in the world. So we brought these approaches into the world. So, for example, the numbers or summation or operators are or assumptions or inventions or way of thinking. So this is where the mathematics comes from. It's a human-centric thing. Of course, you can use this mathematics as a tool in the nature. So the other approach is coming back from the nature. So let's say physics is coming back from the nature. Even if there is no human in the world, there are some natural rules some physical rules, physical laws working already on the world or in the universe. Let's say in a deep space there are some gravity rules already working without any human intervention, but as a human we brought something which never existed in this world, like let's say coins, economy, or let's say mathematics, numbers. These are some assumptions invented by human. So computer science is coming back from this human-centered approach, philosophy, let's say. And then AI is a subfield under the computer science, and machine learning is a subfield under the AI. So as we already talked about lots of different approaches under AI, like let's say genetic programming, genetic algorithms, constraint satisfaction problems, search trees, solving a problem by using a search algorithm, for example, the heuristics. So there are lots of different approaches under AI for solving same problem or different problems. But machine learning is a subfield under AI. So today we are going to start talking about the machine learning. Okay, so we have different approaches, different methodologies, philosophies under the AI, but machine learning is one of them. And of course we have the statistics as a part of the data science. So be careful, there is no intersection between the statistics and the machine learning. So statistics is another discipline coming back from the physics or nature or whatever you call it, because in the statistics we have some uncertainty. If everything is certain, if everything is deterministic, if everything is already known, then we cannot talk about statistics, okay? So in the human world, let's say in the computers, we don't have any randomness. Okay, for example, if you want to generate some random numbers even by using the computers, all the numbers you have generated are called as the pseudo-random, or the algorithms we generate under the computers are called as pseudo-random generators, pseudo-random algorithms, because they are not the exact random algorithms. In order to generate something random, you need something different than the computers, because computers are human design, and as human, we design something deterministic, we design something we can control and we can understand, and under the mathematics. So there is no, okay, I'm talking about the computer part, applied mathematics, or applied mathematics is a subfield under mathematics. I'm just skipping this part for making a straight explanation about the machine learning. But on the other hand, on the statistics, we have something we cannot explain, something or mathematics cannot model. So, for example, something is happening in the nature and there is a randomness on it. Of course, there are some discussions under this part. So, for example, you can go back to the Newtonian physics or the Einstein physics, the quantum physics. Even if you know everything, let's say, on the world, let's say the pressure, the humidity, the weather conditions, all the vectoral powers, can you guess the result of tossing a coin? So tossing a coin is a random event most of the time for us. We cannot expect the outcome of this tossing coin event. But even if we know everything affecting this event, can we predict the result of this event? And in the Newtonian physics, the answer is yes, because you can just simply calculate the vectoral effects on this coin, and then you can just calculate or predict the result of this event. But on the other hand, Einstein brings something new, the quantum physics brings something new. Even if you know everything, you cannot make a prediction about the outcomes of the random events. So let's go back to the difference between the statistics and machine learning. So statistics is a completely different discipline approach than the machine learning. But in the real life, in the data science approaches, we are using them together. Sometimes we are using machine learning as a tool for the statistical problems. Sometimes we use statistics as a tool under the machine learning or AI problems. So by the definition, they are just mixed during the real life applications. Of course, we have the neural computing, which is the source of the deep learning or the artificial neural networks or pattern recognition, which is the discipline holding from some approaches from the statistics or the machine learning. But for now, in order to address the discipline we are dealing with, we need to define that the machine learning is a subfield under the AI, and machine learning is mostly used, one of the biggest subjects used for the daily life data science problems. And from now, from now on, I think we need to talk about the different approaches under the data science. Okay, so since we are talking about machine learning or the data science, we need a project management technique, an approach for solving the problem. So let's say you have a problem and you need to define the clear steps for starting this problem and the next step after you have started this problem. So you need a project management or a management methodology for the problems. And in the literature, there are three approaches, let's say SEMMA, KDD, and CRISP-DM. And unfortunately or fortunately, SEMMA is not used anymore. It's a relatively old approach. It's the source of these two approaches. So it's the parent of these two approaches, let's say. But I'm not going to talk about the SEMMA, but we are going to continue with the KDD and the CRISP-DM. So in order to understand the KDD, which was the shortcut in here for the data science, we need to understand the data information, knowledge, and wisdom pyramid. So if we go back to this pyramid, maybe you are already aware of this pyramid, and you can just skip this slide, but in order to understand KDD, the knowledge discovered on the databases, on the data, let's say, you need to understand this pyramid. So I'm going to go into the KDD steps in here. So it's starting from data to the knowledge, but we need to understand what is data, what is knowledge, and what are we getting from these steps in here. So the data information knowledge pyramid is explaining the steps, the outcomes in here. So let's say in the data step, in the data level, what do we have is the numbers or some strings, characters, and so on. So for example, you have a number, let's say about 100,000. Okay, so 100,000 is just a number and there is no meaning about this number. But if I say it's the salary of a person, then it has a meaning. So in order to gain some information, some meaning, some explanation about this data, you need the information level. And fortunately, these problems are solved by the database management systems, let's say at the end of the 90s. So if you have a database management system, a database, let's say SQL Server, Oracle database, Sybase, or any database management system, PostgreSQL, or let's say MySQL, or any database management system, you can just simply insert a query, write a query. Let's say you write something like select maximum salary from the employee table, and then you get the maximum salary of the employee. So stepping from data to the information is possible by using the database management systems, and it is a clear way of answering the questions in the information level. And all the questions in the information level are clear, explainable. There are always one answer to the queries, to the questions in this level. But if you go to the knowledge level, then you are talking about something we already started to discuss. So as human, we cannot be clear about the answers in this step. For example, let's go back from the salary example. Let's say you have a CV of a person and he is applying for a job, let's say, and I ask a question like, what should be the salary of this person? So there is no clear answer about this. We can even discuss it. And there are lots of dynamics affecting, there are lots of information, data affecting the answer of this question. So it's not clear, okay? It's not clear. And even if we are not clear, how can we expect AI to be clear about these answers? But we can implement, we can develop an artificial intelligence solution even for these questions. So knowledge level is a level that even we are not certain about. But in the knowledge level, we are talking about some context. So we are talking about the salaries of the people. How can we define the salaries of a person? So the journey starts from, let's say, 100,000. So you have the salary of everybody on your company. You can query these salaries, so you can give some meaning on the information level. And on the knowledge level, we are talking about, can we use this data, this previous salary information, for the newcomers, for the people applying for the jobs in our company. So this is just an example for the knowledge level. So we can have lots of different questions at this level, and I'm going to talk about some of them But for now, just to try to understand the knowledge level questions or the problems we are addressing in this level. And on top of knowledge level, we have the wisdom level. Okay, on the knowledge level, we cannot say that all the questions can be answered by the AI. Okay, so there is a fight for the AI, I mean, there is a fight going on the knowledge level, and we are trying to develop new solutions for the new questions, new problems on the knowledge level. But if we are talking about the wisdom level, it's a still very clear area for the artificial intelligence. There are some, let's say, experiences, some studies already started on the wisdom level, but to be honest, to be clear, on the wisdom level, we are talking about something, let's say, okay, first define with an example. On the knowledge level, we are talking about, on the wisdom level, we are talking about problems like what is economy? Do we really need a monetary system? Do we really need an economy? Or what is the use of economy? What is the use of money? Can we find an alternative to the money? Or let's go back to the AI questions from the wisdom level. Let's say, can we develop an AI which can replace the monetary system or the economic system? So this is a question in the wisdom level. And as a human, we have invented the economical systems, monetary systems, we have invented the money, but can we expect from AI to invent something similar to this wisdom level? And unfortunately, the answer is not very simple yes. Maybe in the future, maybe, we can have some answers, some solutions coming from the AI, but it is not a clear yes yet. So this is just a sci-fi after this point on. Okay, so there are some other visualizations about the data, information, wisdom, or insights. There are some other steps between, let's say, the measurement, maybe might be the base of the data, because in order to collect the data you need some measurement. Maybe intelligence can be a vertical in here, or you can have some insights in here. So there are other visualizations you can easily find on the internet, but I think you get the key concepts about this terminology. And if we go back to the project management techniques in data science, we can talk about the KDD steps in here. So KDD is starting from the data level. If we go back to the pyramid in here, we are starting from the data level in here, and we are going until to the knowledge level. We don't go to the wisdom level, and we jump through the information level in the KDD approach. So you see, we start with the selection of the data. We use some pre-processing techniques. So I'm going to talk about these later on, but you need to select which data is useful for you. Okay, you start with the selection process, and then you use some pre-processing, like handling the problems like the dirty data, noisy data, or missing data. So you have some problems in here. And after all, you need to transform the data, because in the data mining step, we have some algorithms for solving these problems. And unfortunately, we cannot say all algorithms are capable of handling all types of data. For example, maybe you need some normalization, maybe you need some encoding, maybe you need to convert your data, transform your data to the, let's say, using some dimension reduction techniques like PCA or LDA or so on. So transformation is a way of looking data from another dimension, another point of view, or sometimes converting data to another form. And then finally we have the data mining in here, which we use the machine learning algorithms or the statistical algorithms sometimes. But since we are talking about the machine learning under this course, so we can address the machine learning algorithms in here. And then the interpretation and evaluation starts, and finally we have the knowledge, if we can satisfy the evaluation criteria in here. So let's talk about a real life problem like assigning a salary to a person or calculating a salary of a person from the CV of a person. Then you need to select some data, let's say from the HR database, about the previous salaries or already working people's salaries, employee salaries. You select this data from your HR database, and then you make some processing on it, like maybe some people have some missing value about the birth dates, about their previous educations, and you need to handle these problems. And then you need to transform this data to a processable form of data for your data mining algorithm. And let's say you pick an algorithm with the KNN, let's say k-nearest neighborhood, and then you are going to find the nearest people on your HR database to this person, this applying new candidate. And this calculation, this distance calculation, let's say you are going to find 5 people which have similar let's say experiences, education on your HR database, and then you are gonna get the average of these 5 people on your HR database. So this is the data mining part, the machine learning part, and then you make an evaluation. Okay, an HR expert perhaps checks for the results, and if the results are satisfying, then you have a salary suggestion for this new candidate. So this is the knowledge level answer, and we can of course debate about this result, but it has a result after all. And this is the KDD approach, the one of the approaches we can use for the data science problems using the machine learning. On the other hand, another approach is called as the CRISP-DM, Cross-Industry Standard Processing for the Data Mining. It's a circular approach, a cycle we have in here, and there are 6 steps for solving the problem. So we start with the business understanding, we continue with the data understanding, and there is a loop between these 2 steps. Be careful about it. So most of the time, after you have some certifications or diploma, let's say, about the data science or let's say machine learning, people appears and asks you about, okay, I have a data in here, what can I do with this data? Okay, you are going to face with lots of similar questions in this industry. And you need to be careful about it. You cannot go to data understanding before you have a business understanding. Okay, you need to ask the question, first of all, what is your problem? What is the problem, and a clear definition of the problem. And then you can start the data understanding, collecting the data, and so on. Okay, so in here, there is some, okay, let's say, if you don't have any business problem, if you don't have a business understanding but a data set, let's say, then most probably you are going to end up with a storytelling. Okay, if you are jumping the problem, if you are jumping to the data science machine learning solutions without any data understanding, you are then without business understanding, then most probably you are a storyteller. If you have the business problem, business understanding, but you don't have any data, then most probably you are the fortune teller. So in order to not be a fortune teller or a storyteller, you need to go step by step and pass these steps clearly, okay? So a successful data science or machine learning project can only appear after a clear business understanding and the data understanding. And let's say if you pass these steps, the business understanding and the data understanding, then you go to data preparation, and it's the one-way pass. And in here we use the data pre-processing steps like handling the data, dirty data, noisy data, or even the transformations like normalizations and codings and so on. And then you have the modeling in here. And there is another loop in here from modeling, because there might be some requirements from the modeling algorithms about the data. So you need to do some data preparations a couple of more times, and then after you have a clear model, a candidate model, you go to the evaluation, and if you satisfy the criteria on the evaluation, you have the deployment. Otherwise, you go back to the business understanding and you go through this loop many times until you satisfy these conditions in here. Okay, so these are the project management techniques, the steps we need to take care of during a project. Okay, so for your projects, you also need to apply these methodologies for clear understanding, and also it's important for the documentation or passing some knowledge about this project to the project members or the future members of the project. So I'm going to talk about the analytics, data analytics and data analysis, the difference between the data analysis and data analytics. But before going into these steps, I'm going to stop my video in here, and I'm going to leave this content to the next video. So until the next video, enjoy the machine learning.